Assalamualaikum student. Today we will discuss about Heaviside step function. As we have started Laplace transformation, now we will know about the Heaviside step function. First of all, we will know what is the step function. Any function t minus k will be equal to 0 when our t is less than k and 1 when our t is greater than k. We will call it step function because it will change like a step. Now we will write or we will graph this step function. This will be like our function. For example, this is our time domain. Okay, here is our 0 as time is equal to 0. At any point k, we have started our signal. This step function is used when we are dealing with signals on and off situations. When our time is less than k, our function will be equal to 0. Means when we will here, our function will be equal to 0. When we will jump from k, then our function will be equal to 1. Here our q t minus k is equal to 1, and here our q t minus k is equal to 0. Now we will see its Laplace transformation. We will write as Laplace transformation of any function f of t is written as f of s. This is equal to Laplace transformation of f of t. Our Laplace transformation will change our time domain to s domain. Now we will write its integral form. Our f of s will be equal to, because we have started from 0 to k, I will write from 0 to k, and our function will be t minus k exponential minus st dt plus this will be equal to k to infinity. T minus k exponential minus st dt. This is our Laplace transformation of our given function. Here you can see that our function is 0 when we will move from 0 to k, and our function is equal to 1 when we will cross the point k. Now I can write, because in this limit when we are in the region of 0 to k, our step function is equal to 0, our q of t minus k is equal to 0, so our whole function will be equal to 0 plus k to infinity. Our q t minus k is 1 in this domain. You can see that here when we are in this region, I will highlight this. when we are in this region, our whole function is equal to 0. When we are in this function or in this domain, our q of t is t minus k is 1. That is why I have used 1. So I can write this 1 exponential minus s t d t, and we can write k to infinity minus s t d t. Now we will multiply by minus s and divide by minus s, because our exponential is minus t, so here minus s dt, and the whole will be equal to minus 1 over s exponential minus st. Here is our limit 0 to infinity, and I can write minus 1 over s. And first, when we will use infinity, this will become 0, and when I use here I have k. This is not 0, this is k. This is k. Now when I will use k, this will become minus k t. Now our whole function will become minus 1 over s, and here is minus k t. This will become minus kt divided by s, and this is our final answer. This will become f of s exponential minus kt over s, and this is our final answer. This is our final answer. Now I will solve another example of Laplace transformation, which is for example, our f of t is exponential minus kt, or exponential. Our f of t is equal to exponential kt. Now we will transform this function into S domain. As we have know that our f of s will be equal to 0 to infinity f of t exponential minus st dt. This will become equal to 0 to infinity. Our f of t is exponential kt, and we can write minus s t dt. Now I can write this 0 to infinity exponential. Now we will add the exponential kt minus st dt. Our answer will become f of t 0 to infinity exponential. We will take a common minus t, exponential minus t, k will become minus, so I will write it here. S will become positive and k become negative dt. Now you can use the substitution method, but I will solve it directly. Here I will divide s minus k, and also I will multiply this term minus t s minus k s minus k here. Sorry, you can use minus 1 over s minus k because here we have minus sign beside t. Okay, this will become k minus s, and I will multiply this term. Sorry, you can write s minus k, and here you can also write minus 1. This minus is of exponential, due to exponential. Now here we have differential of exponential term, so I will write this minus t s minus k, and our limit is 0 to infinity. You can use substitution method, but this is your choice. I will solve it directly. This will become 1 over k minus s, and when you put this limit, our first function will become minus infinity, our second function will become exponential of 0, and this will equal to 1 over k minus s, and when exponential is in the denominator and our limit is infinity, so this whole function will become 0 and we will left with only minus 1, and this will equal to s minus k, and here is our answer. I can write this: our f of s is equal to 1 over s minus k. In this Laplace transformation we have used f of t is equal to exponential kt. This is our answer. So guys, thank you so much for watching my video. If you like it, do subscribe and share it with your friends.